The challenging part of this question when it comes to the interval of convergence is testing for the endpoints. But first of all, let us go ahead and compute the radius of convergence. So note that a sub n, that is the nth term, is given by x minus 1 to the power n, then everything divided by n, 5 to the power n. We are going to use the ratio test. So remember, the ratio test has an plus 1 term divided by a sub n. So what we're going to do, we're just going to compute this, and then we're just going to apply the limit. Okay, so let us compute this ratio. So a sub n plus 1, it means where there is n, I put n plus 1. So this is x minus 1 to the power n plus 1, then divided by, this is just n plus 1, then this is 5 to the power n plus 1. Okay, then let us go ahead and multiply, because we are dividing, so we multiply by the reciprocal. So we have n, 5 to the power n, divided by x minus 1 to the power n. Okay, now you can realize one thing, that I can write this as, so let us just say x minus 1 multiplied by x minus 1 to the power n, then n 5 to the power n divided by n plus 1, then 5 multiplied by 5 to the power n, then x minus 1 to the power n. So observe that x minus 1 to the power n and x minus 1 to the power n is common, and 5 to the power n, 5 to the power n is common. So because of this, we remain with, so let me just write x minus 1 in the numerator multiplied by n divided by n plus 1 multiplied by 5 in the denominator. Now we can go ahead and apply the limit. So when you apply the limit, you have outside, because the limit is taken in n, so x minus 1 divided by 5 is constant, so we can take x minus 1 outside divided by 5. Then I take the limit as n goes to infinity of what is inside is, so this is just the absolute value, right? So what is inside is the absolute value of n divided by n plus 1. Okay, so you can see that as n goes to infinity, this is just 1 divided by 1 or plus 1 over n. So this gives us x minus 1 divided by 5, right, multiplied by 1, which I don't write. Okay, so in a nutshell, when you take the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n, you get x minus 1 divided by 5. Okay, now remember, for using the ratio test for this series to be convergent, this limit has to be less than 1. So what we're just saying here is that, therefore, for convergence to hold, we need x minus 1 divided by 5 to be less than 1. Okay, so this is just the same as, so this implies x minus 1 is less than 5. Okay, and this is the radius of convergence, which is your r, which is 5. Okay, now let us go ahead and solve this inequality. So we have negative 5 less than x minus 1 less than 5. Okay, so if you add 1 throughout, you get negative 4 less than x less than 6. Okay, now what it means to test for the endpoints, you want to find out whether the series is convergent when x is negative 4 and when x is positive 6. So let us go ahead and do that. So when x is equal to negative 4, what we have is that this series becomes n equal to 1 to infinity. So let me remember the series is x minus 1 to the power n, right? So when x is -4, you just remain with -5 to the power n, then divided by n, 5 to the power n. So we can rewrite this as summation as n goes to infinity from 1. Then -5, I can just write it -1 multiplied by 5 to the power n. This is -1 to the power n, then 5 to the power n, then everything divided by n, 5 to the power n. So 5 to the power n and 5 to the power n cancels, so we remain with n 1 to infinity -1 divided by n. Okay, but now when we use the which is going to be convergent, right? So this is convergent, right, by the alternating series test. Okay, why is it convergent? Because b sub n here, you observe that b sub n is equal to 1 over n, which goes to 0 as n goes to infinity, and b sub n is decreasing also. Okay, now let us go ahead and check. So you can see that x minus 4, x equal to -4 is included. So what about when x is 6, right? So when x is 6, substitute in the original expression, you remain with n equal to 1 to infinity 5n divided by n 5 to the power n. And this simplifies to 1 divided by n, which diverges, right? This is a divergent harmonic series. Okay, so let us conclude here. So therefore we said the radius of convergence is 5, and the interval, let me just denote it by I, the interval of convergence is equal to, we said 4 is included, so we have -4, 6, which is not included, and we end it like that. Let us find the radius and the interval of convergence for this wonderful series. So the nth term is given by this expression. The first step is to take the ratio of a sub n plus 1 divided by a sub n, which is this expression. Okay, now let us go ahead and simplify this. So you can see that in the numerator we have x plus 1, x plus 2, then x plus 2 to the power n, then I multiply by n squared, then divided by the denominator. I can expand this expression, which is n squared plus 2n plus 1, right? Then multiply by x plus 2 to the power n. Okay, so x plus 2 to the power n is common in both cases, so that goes outside. Then this is the absolute value of, I can take x plus 2 outside. X plus 2 outside. Remember, the radius of convergence, or the interval of convergence, is determined in x, right? Then inside I remain with n squared divided by n squared plus 2n plus 1. Okay, but what you will observe is that when n is large enough, in this case, this just reduces to the absolute value of n squared over n squared, right? Because 2n plus 1 will not contribute anything. So this will be equal to 1. So in a nutshell, if I take the limit, right, the limit as n goes to infinity of a n plus 1 divided by a sub n, this should just be x plus 2. Okay, and for this to converge, for this series to converge, we need x plus 2 to be less than 1, and this is the radius of convergence. R is equal to 1. Now the next thing will be to solve this inequality, which is x plus 2 equal to x plus 2 less than 1. Okay, so this is just -1 less than x plus 2, then less than 1. Let us subtract 2 both or throughout. -2 -2 -2. So you have -3 less than x less than -1. Okay, now when you find this inequality, right, this is not the last answer or the final answer, because we need to test the endpoints. So let me just remind you. So recall that the series is x, the summation from 1 to infinity of x plus 2 to the n, then everything divided by n squared. Okay, so when x is -3 at the end point, -3 plus 1 will just be -1. So this is summation of what? -1 to the power n divided by n squared. So this is a series which is absolute convergent. Okay, so meaning that at x is equal to -3, the series converges. Then at x equal to -1, in the same way, when x is -1, you just have 1, right? That is -1 plus 2, which is 1 to the power n, you have 1. So that is 1 over n squared, which also converges, right? By the p test. This is p is equal to 2. P is equal to 2, which is greater than 1. Okay, so because it converges, the series converges at both endpoints, the radius of convergence is 1, and the interval of convergence is included, right? So you include the endpoints, -3 to -1, included like that.